recall the trigonometry formulae, the 6 trigonometric ratios. Given sin theta is equal to O by H, cos theta A by H, cosine theta H by O, secant theta H by A, tan theta O by A, and cot theta is A by O. And Pythagoras theorem H square is equal to A square plus O square, where the symbols A stands for adjacent side and O stands for opposite side, H stands for hypotenuse. Remember the formula to work out the problems on this. The next problem is, I will read the problem. If angle A and angle B are acute angles such that cos A equals cos B, then show that angle A is equal to angle B. As per the given data, there are two triangles. In the triangle, A is acute angle of one triangle and B is acute angle of another triangle. Let us represent them, both the triangles. This is one triangle with angle A, another triangle with angle B. That is as according to the given data. Then you have to show that these angles are equal. They are called corresponding angles. A equals B. To prove that, first of all, you have to prove these two triangles are similar triangles. Then this holds good. Now, what is the proof for that? In this triangle, the sides are represented with respect to angle A, that is adjacent side, opposite side, hypotenuse, and call this as triangle 1, A1, O1, H1. In the triangle 2, with respect to angle B, this is adjacent side, opposite side, hypotenuse. For a second triangle, it is A becomes A2, O becomes O2, H becomes H2. Hypotenuse. Let me write the definition of cos A. Cos A is equal to A by H. What is A here? A1. H is H1. And write the cos B. Similarly, write the cos B adjacent by hypotenuse. Here A2 by H2. Given cos A equals cos B, then the left hand sides are equal. If the left hand sides are equal, then right hand sides must be equal. This is what we get the equation. It can be rewritten. It can also write as given by interchange, cross multiply. That is H1 by H2. Here the ratio, there are two different triangles. Ratio of the corresponding sides, adjacent sides, and this is the ratio of the corresponding sides, H1 by. They are equal, that means constant. Let us write it as the constant value, because if the ratios are same, then must be constant value. This is a constant value, this is a constant value. That is K is a constant. If that is the case, we can be able to prove the ratio of these sides are equal if the ratio of these two sides is same or different. If you prove, then these two triangles are similar triangles. Let us check. Let us take the ratio of this O1 by O2. So to prove this, K or not, take this O1 by O2. What is O1 from this diagram? Pythagoras theorem. That is root of H1 square minus A1 square, because O1 square is equal to h1 square minus a1 square. That is by root O1 is equal to. Similarly, O2 is equal to Pythagoras. h2 square equals O2 square minus a2 square. Or O2 square is equal to h2 square minus a2 square. O2 is the root of that. So we have substituted for this using Pythagoras theorem. Then we get this. From this equation, one look at that. This is a constant. This is a constant. If this is a constant, what is h1? K into h2. This is constant. A1 is equal to K A2. Let us put these into the equation 2 and simplify. What is h1? K h2. What is a1? K a2. Put them into, because square is there, whole square. Whole square. K square h2 square. K square a2 square. Let it be as it is. Then simplify this. K square is common, take out common factor. K square root becomes k, out of root. Remaining as it is. Then these two are same, get cancelled. Then O1 by O2 is equal to k. Thus proved. Means, just make pass. It is thus proved. V1 O1 by O2 equals k. Look at this, already we have this ratio is equal to k. Then this also k. Therefore, we can write it as this is a1 by a2, h1 by a2, h1 by h2, o1 by o2. Corresponding sides, the ratio are same. If that is the case, these two triangles are similar triangles. These two triangles are similar triangles, then their corresponding angles must be same. Thus, angle A equals angle B. Angle A of this triangle equals angle B of this triangle if cos A equals cos B for this trigonometric ratio. Is it not? So this holds good not only for cos A, for all the trigonometric ratios. Even if it is sin A, sin B, that also holds good. Or cosecant A, cosecant B. The same thing holds good. Tan A, tan B. Cot A, cot B. Secant A, secant B. Then these angles must be same. So if it is, for one of the trigonometric ratios, if you prove like that, it is also similar to all other trigonometric ratios. These are similar triangles. When this is the case, this formula stands, holds good, then those two triangles are similar triangles. The corresponding angles are same.